Today I'm going to be teaching you how to solve a problem like this one right here. So our first step for this is going to be to balance the equation. As you can see, we only have one aluminum on this side but two on this side, so we're going to need to go ahead and add a 2 there. We've got 3 oxygens on here and 3 oxygens here, so that's balanced, but we've got 1 iron here and 2 there. So we're going to go ahead and put a 2 right there. Now our next step is going to be to write down what we know. We know here from the question that we have 30 grams of aluminum and 95 grams of iron oxide, which we will put here underneath. But we are trying to find how much iron is produced, so we're going to go ahead and add a question mark right there. Now our next step is going to be to convert each of these into moles. So we're going to start here with the iron oxide. I've got the atomic weights of each element up here, and we're going to write out the equation here for the atomic weight of a mole of iron oxide. Now I've written out here the equation to find the atomic weight of iron oxide. You've got 2 times the iron molecules and 3 times the oxygen molecules to make 159.68 grams per mole. Now we know that we have 95 grams, so in order to find out how many moles of iron oxide we have, we are going to divide 95 by 159.68, and we are going to get 0.5949 moles of iron oxide. Now we are going to do the same with the aluminum here. I've gone ahead and done the math and found that we have 1.1119 moles. Now our next job is to identify the limiting reactant. So the first step on finding our limiting reactant is going back to the problem here. We're going to see that we have 2 moles of aluminum for every 1 mole of iron oxide. That means that we are going to go ahead and double the iron oxide. 0.5949 times 2 would equals 1.1898. Now as we can see, 1.1119 is smaller, so aluminum is going to be our limiting reactant. Now since we know that for every 2 moles of aluminum we get 2 moles of iron, and we know that we have 1.1119 moles of aluminum, we know we also have that much iron. So we're going to convert 1.1119 moles of iron into grams of iron. In order to do that, we are just going to multiply the number of moles by the atomic weight here. And that is going to come out to be 62.088 grams. So now we know, given 30 grams of aluminum and 95 grams of iron oxide, we will have 62.088 grams of iron.